So, again, we're going to factor completely. So everything that you see that you have to factor in your life, you assume from here on in, you factor really completely. Now, this is what factor completely really means for us. It really means to always do this first. Step 1, factor out the greatest common factor for the terms. Okay, so here's our factor completely strategy. Now, what's the greatest common factor of these three terms? You got x cubed, right? You got 5x squared, and you got your 6x. So you're right. The GCF here is just x. Okay, so here's my greatest common factor. Now, remember, I'm going to say to you, if my greatest common factor is x, what's the quotient? What's the quotient that we call q? Remember, when you factor out a greatest common factor, factoring out a GCF was a procedure. This is the first step. The second step in that procedure, right, was to determine the quotient. Is that right? So I told you guys, okay, once you get the GCF, determine that Q quotient, and then you say, well, how do I get my quotient? Well, what do you originally have? X cubed plus 5x squared plus 6x, that's what we originally have. Divide by your GCF, the greatest common factor, and what you end up with is what we call the quotient. Okay, so this is going back to what we did in the beginning, factor out the greatest common factor. Okay, so again, we now find the quotient. We say, okay, I know I have three terms here. Now this is what I call my Q for quotient. Each term, we're dividing by x, that GCF. Okay, and so what do we get for this quotient? We get what? X squared plus 5x plus the 6. So this is my quotient, and then we said step 3 was to write your answer. And you write your answer, if you guys remember. How do you write this answer? Isn't it always the greatest common factor times the quotient? So what you have here is this. Originally, we have x cubed plus 5x squared plus 6. If I factor out the greatest common factor, we get x for the GCF, we get x squared plus 5x plus my 6. Now, this is the procedure known as factor completely. So my first step is to factor out the greatest common factor. I just did. I wrote my answer. And then finally, let's call this step 4 for the factor completely strategy. Factor the what? Quotient. So what you're going to do now here is factor x squared plus 5x plus 6, because that's my quotient I just found here. That's the Q. Okay, we just found this quotient. And that's now what we need to factor. So what you do is you take a very good look at the quotient, and then you ask yourself, can you factor this, right? And you would know how to factor x squared plus 5x plus 6. So when you go look at this and we say, okay, we're going to factor this, let's recall, what recipe do I use to factor x squared plus 5x plus 6? Right? Remember that? Because this, now at this point, we have options for factoring that quotient, right? We have various recipes. We had x squared plus bx plus c, right? Remember that was the first one? That's our first trinomial recipe. We got ax squared plus bx plus c. We had difference of perfect squares, right? I think we kind of wrote that down. We had a formula for it. A squared minus b squared. We had a difference of perfect cubes. A cubed minus b cubed. We got a sum of perfect cubes. So these are all the techniques that we went over. Which technique do you guys think you use here to factor this x squared plus 5x plus 6? We're going to have to use what? That technique. So that technique is back. So it's good that you guys studied this and you worked on those problems, because we're now going to factor x squared plus 5x plus 6. How do you factor that? Do you remember? Wasn't this x times x? What were the factors? Plus 3 and what? Plus 2? Okay, do you guys remember this one? That's how you factor the x squared plus 5x plus 6. The product has to be 6. The sum has to be what? 5. So you factor this already. Now, step 5 here, you're done here. Here's step 5. You're going to write your final answer. Final answer, don't forget what the greatest common factor was. This is x times x plus 3 times x plus 2. My greatest common factor, that x, I bring down here. So my final answer here for factoring completely is really this x, greatest common factor, times x plus 3 times x plus 2. So here's what you're going to have to do, okay, to factor this trinomial completely. I'll write the answer here. X plus 3 times x plus 2. This is the answer for factoring this trinomial. And again, this process is known as factor completely. So I'm going to summarize factor completely, right? Just take out the greatest common factor first, and then factor your quotient. That's it. You're now going to factor this way forever, and that's going to pretty much complete your factoring career. We're going to use these things in the future. We're going to use this information, but for now, we're just going to factor completely. So take a look at the next question. I have this on your website, factor completely. We have x to the fourth now, plus 12x cubed, plus a 35x squared. Okay? And again, what's the first step? Factor out your greatest common factor. So what's the GCF here? You got x to the fourth, you got 12x cubed, and you got 35x squared. X squared. Isn't it x to the smallest power? Do you guys remember that? X to the smallest power. So if this is my GCF, can you guys tell me, what's the quotient going to be? How do you get that quotient?
X squared.
Say x to the fourth, right, plus 12x cubed, plus my 35x squared. Okay, let's find the quotient. We'll put it over here. We're going to divide every one of these terms. Okay, we'll start off that way. Divide every term by the GCF to get this quotient. We get x to the fourth over x squared, 12x cubed over x squared, 35x squared over x squared. We get x squared plus 12x plus 35. Here's our quotient. So all together, this is x squared times x squared plus 12x plus 35. Again, let's point out greatest common factor and my quotient. Okay, but you're not done, because what do you have to do now? You factor the what? The quotient. So what recipe did you guys use for factoring x squared plus 12x plus 35? Do you guys actually know what I did? I went back to your worksheets under this section, and I took some of those problems there. So I already know you know how to factor x squared plus 12x plus 35. So how do you guys factor that? Do you guys know? You did it already. Let's see. Let's write it here. What do we get? x and x. Okay, product is 35, sum is 12. What are the numbers? 5 and 7, you're right. Okay, don't forget to bring down your GCF of x squared. You're going to put it right here. So you put that right there, x squared, and pretty much you have your final answer. It's right here. It's x squared times x plus 5 times x plus 7. So we can erase some of this and write it completely. X plus 5, x plus 7. Anybody have any questions on this one? Okay, again, we're factoring what? Completely. Okay, factoring completely. Well, that was number 3, right? So that makes us number 5, I guess. Let's do some. Next example, number 5, we got x cubed plus 10x squared plus 21x. GCF. What's your greatest common factor? Greatest common factor is x. So you have x cubed plus 10x squared plus 21x, everything over the GCF of x. So let's get this quotient. This quotient is going to be x cubed over x plus 10x squared over x plus 21x over x. Right? You get x squared plus 10x plus 21. That's my quotient. So together we have x times x squared plus 10x plus 21. Okay. Yeah, we don't need the headphones. All right. So what do you guys do next? Factor the what? Factor your quotient. X times, right? What is it going to be? Right? The product has to be 21 and the sum is 10. So what do you guys get? Okay, that's 7 and 3. Good. There you go. Right, factor completely. So if you have to go back to that homework assignment, go back to that homework, redo some of those, clear out the cobwebs, and now you got some good factoring. Factor completely. Number 5. Seven, we got x to the 4th plus 4x cubed plus 4x squared. Okay. Greatest common factor for your terms. Right? At 4, 3, and 2. What power is smaller? 2? Okay. X squared is greatest common factor. So, let's find the quotient. X to the 4th plus 4x cubed plus 4x squared. Divide every term by your x squared. And we end up with x to the 4th over x squared, 4x cubed over x squared, 4x squared over x squared. So we get x squared plus 4x plus 4, and this is my quotient. So we're going to write this as x squared plus 4x plus our 4. Okay, don't forget, greatest common factor, and over here we have that quotient. So factor the quotient now. What do you get when you factor the quotient? X plus 2. X plus 2. So you can write your answer this way, right? Or we can say, we can write our answer where the x plus 2 is considered a base for an exponential because it's repeat multiplication. So either way would be fine. I would accept either as an answer. And you had factored this problem completely. Okay, number 7 is factored completely. All right, and again, we're going to use this in the future, so this is your process. Always take out the greatest common factor first, always, and then factor what remains as the quotient. Okay, anybody have any questions on this one? All right, that's example 7. So let's see example number 9. 2x squared plus 2x minus 12. We're going to factor completely. Greatest common factor. What's my GCF now?
2.
It's 2. Is it just 2? Yes. Yeah, because x isn't even common to each term, right? See, there's an x squared. There's an x, but there's no x term with this number. So x isn't common. It could never be part of the greatest common, the largest common factor. Okay, that's a good job. Okay, when I wrote that, I thought, okay, let's see who we can catch with that one. So we get 2x squared plus 2x minus 12. Right, everything over the GCF of 2. So we get what? 2x squared over 2 plus 2x over 2 minus 12 over 2. This gives us x squared plus x minus my 6. I got my quotient here. I got my GCF. So 2 times x squared plus x minus the 6. What do we do with this quotient? Factor that quotient. And again, that recipe, if you guys recall, right, this particular recipe, my product has to be negative 6 and the sum is positive 1. What numbers are they?
-2 and 3.
Good. Positive 3, negative 2. And you are done. Okay, you guys okay with this one? Okay, what do you guys think? Is that okay? It's all right. If I ever go to the movies, when you go to the movies, where do you guys sit? In the corner? No? You guys sit in the corner, or do you sit, where do you guys sit? I try to sit in the middle up front. Okay, so you guys know what I'm saying? You guys want to sit in the middle. Greatest common factor. What's the GCF? Just 3. You got x squared, you got x, and x isn't even common, so all right, fine. Let's find the quotient. Okay, GCF is 3, so we get 3x squared minus my 15x plus 18. A quotient means, what's the answer when you divide? I guess I have sum and difference of terms, so I have to divide every one of these by 3. And I get what? X squared minus 5x plus 6. This is that quotient I get. So we write this as 3 times an x squared minus 5x plus my 6. Okay, so this is so far what we get if we factor out the greatest common factor. And then we factor this what? Factor this trinomial by whatever recipe is called for. Is that chicken soup? I think so. X and x. Right, my product is positive 6 and my sum is negative 5. What'd you guys get? Negative 3, negative 2. There you go. Factor completely. That one's number 11. Let's try 13. Two x cubed minus 22x squared plus 60x. Okay. Greatest common factor. Oh, let's see. Well, for the numbers, what is it for the numbers? 2. Now, what about x cubed, x squared, and x to the first? X to the first, which is just x. You guys okay with that one? So here's an example where the GCF is actually 2x. So let's find this quotient. Two x cubed minus 22x squared plus 60x divided by the GCF of 2x. So we get 2x cubed over 2x minus 22x squared over 2x plus 60x over 2x. So what do we get here? 2's cancel, right? And you have x squared minus 22 divided by 11 is 22 divided by 2 is 11. X squared over x is just x. And then 60 divided by 2, isn't that 15? And x over x cancels. So here's my quotient. So this is all the work we did when we did our division. Let's write our answer. So GCF is 2x, quotient x squared minus 11x plus 15.
Mister, isn't it 30?
Oh, you're right, 30. Good job. Thank you. Okay. All right, let's see. What do we do next? You guys know? Factor the quotient. And what technique is this? Chicken soup again. So what two numbers multiply together is positive 30, but when added is negative 11. Negative 5 and negative 6. Good job. You guys know how to factor. That's good. All right. So now we factored what? Completely. Okay, so now you guys factored these completely. Nice. 13. And then we have 15. Let's see what 15 is. 3x to the 4th minus 36x cubed plus 81x squared. Okay. We're going to need the greatest common factor. All right. What's the GCF of 3, 36, and 81? You guys know? What's the greatest common factor? 3. X cubed, x to the 4th, x cubed, x squared? 3x squared. Good. Let's get our quotient. 3x to the 4th minus 36x cubed plus 81x squared. Divide by the GCF of 3x squared. So 3x to the 4th, 3x squared minus 36x cubed, 3x squared plus 81x squared over 3x squared. Let's get the quotient. X squared minus 12x plus, what do we get? What's 81 divided by 3?
27.
It's 27. Don't forget the x squareds go away. X cubed over x squared is x, and then x to the 4th over x squared is x squared. So here's the quotient now. All together, let's write it down. GCF, 3x squared. Quotient, x squared minus 12x plus that 27. Let's factor the quotient. How do we factor x squared minus 12x plus 27, right? Two numbers multiplied together is 27, added negative 12. What are they? Negative 9 and negative what? 3. Is that true? I think you're right. There you guys go. Factor completely. So it's number 15. Okay, anybody have any questions on this one? Factor completely. So we got 17 now. 4x to the fifth minus 8x to the fourth minus 96x cubed. So GCF here. 4 x to the fifth, x to the fourth, x cubed. Isn't that x cubed? Okay. So we have 4x cubed minus 8x to the fourth. Just simply divide your problem here with that GCF. We get 4x to the fifth over 4x cubed minus 8x to the fourth over 4x cubed. Oops, that's a minus. Minus 96x cubed over 4x cubed. Now let's find what these quotients are, this big quotient. What do you guys get? X squared minus 2x minus 96 divided by 4. Is that 24? I think so. Here's my, bless you. Here's my quotient. You guys okay with that? So we write this GCF. 4x cubed. Quotient x squared minus 2x minus 24. Factor the quotient. It's all right. Okay. You guys okay with this one? Let's factor the quotient. What do you get? 4x cubed. X and x. So what two numbers multiply together is a negative 24, but when added is negative 2.
4, -6.
Negative 4, negative 6?
No. Positive.
Positive 4 and negative 6. Is it important to get the signs right? Yeah, it's very important. Yep, absolutely. And you guys typically did that. Sometimes on tests people don't get signs correctly, you know, but you guys pretty much consistently got your right signs. So good. You know, and if you need any more practice on factoring with this technique, x squared, you know, plus bx plus c, go back and work on those worksheets again. You look at those video solutions and try that out all over again, because you don't want to forget this, because it's part of factor completely. And, you know, in your life, when you factor, that's what they assume. Factor completely. All right, let's do another one. We get 10x to the fourth minus 40x cubed plus 40x squared. All right. Greatest common factor. What's your GCF? 10, 40, and 40 is in the number 10?
Yes.
What about x to the fourth, x cubed, and x squared? Okay. Now let's get the quotient. 10x to the fourth minus 40x cubed plus 40x squared. Everything over 10x squared, the GCF. Let's be consistent. So 10 and 10 go away. Doesn't that just give me x squared here? 40 divided by 10, that's minus 4. That's minus 4x because my powers, right? Subtract the powers. And then 40 divided by 10, again, is 4 x squared over x squared. Here's the quotient. So altogether, 10x squared times x squared minus 4x plus my 4. We now factor the what? Factor this quotient. So,
The 10x squared is the one that goes into all of them, correct?
yes, it will divide each one with a zero remainder. That's correct. What are the numbers here? Product is positive 4. Sum is negative 4. Did we do this correctly? You okay with that? Is it negative 2 and negative 2? I think you're right. We can write this as 10x squared x to the minus 2 to the second power. Either way is fine. Okay? So you factored number 19 here. Yeah, good job. All right. And again, this is called factor completely. Always take out the greatest common factor and then factor the quotient. So we have 8x squared plus 44x plus our 60. Okay. All right, what's your greatest common factor again? Anybody know? What is it? It's 4, not 8, right? 4. Now, what about x squared, x, and then no x, right? X squared, x, and no x. X is not common, so it can't be the greatest common factor. In order to be the greatest common factor, it has to be common. Now, here's my quotient. 8x squared plus 44x plus my 60. Going to divide by, what are you going to divide by? Greatest common factor of 4. Okay? My quotient. So, 8x squared over 4, 44x over 4. All right, 8 over 4, isn't that 2? 44 over 4, isn't that 11? And then what's 60 divided by 4? Is that 15? Here's my quotient. 4, 2x squared. 11x plus my what? Plus my 15. Okay? Factor the quotient. Now, what do you guys notice? What do you guys notice about this quotient? What recipe? Ax squared plus bx plus c. Is that true? Okay, so there's no guarantee that you get a quotient that's chicken soup. This one is, what is this one? This one's beef stew or chicken noodle, right? It's slightly different. Thank you. All right, it's a little different. You guys remember this recipe? Excuse me. If you don't, what should you go home and do? Go practice this recipe because, again, it's part of your factoring, your overall factoring strategy of factoring completely. So let me let you guys know there's another way to do this. It's by trial and error. You guys know that? So 2x and x, let's say you went home and you practiced this recipe. These are my factors of 2x squared, right? The first terms. I just have to find the outer and inner term, or the last two terms there. Well, let's see. What do you think it should be? 5 and 3? How about 5 and 3 here? Is that going to get us the answer? No. Is that true? No. Well, let's think. What's 2x times x? Isn't that 2x squared? What are my last terms? 5 and 3 is what? 15. What are the O and I terms? Outer terms. What's 2x? O and I terms. Yeah, 2x times 3 is what? 6x. Inner term. 5x. Oh, what do you guys notice? That is 11x. So, by using what we call trial and error, finding factors of the first term, factors of the last term, we were able to factor this. Now, some of you guys know how to do this, right? Some of you guys know the trial and error technique, and if you do, then that's good, that's fine. If you don't know the technique, let's say, what do you guys do? Do you guys remember? Let's put this. How do you factor 2x squared plus 11x plus that 15? What would you do here? Go through your procedure. Give me two numbers, multiply together. The product has to be what? 30. Wasn't that A times C? Go home and do that homework again. Sum is 11. And you found the numbers to be 5 and 6. This is not my answer. Remember that first step? And you said, okay, let's rewrite. 5x, 6x, 15. Now you factored by grouping. So greatest common factor here is x, 2x plus 5, and then 6 and 15. Isn't that 3? 3, and then our quotient's 2x plus 5. Common, 2x plus 5 times x plus 3. Isn't that what we already got over here? So in other words, go back and factor using the chicken noodle recipe or the beef stew recipe, whatever you want to call it. It's not the same recipe, so be careful. And review that homework if you have to, because it's back. Okay, you guys okay with that? So final answer right here is what you see. All right, so that's number, see what number that was. That's number 21. Good. Anybody have any questions? You guys okay with that? All right, 23. 15x squared plus 65x plus our 20. So what's the greatest common factor? What's my GCF here? Is that 5? My quotient, 15x squared plus 65x plus 20. Everything divided by what? By 5. What do we get? 15x squared over 5 plus 65x over 5 plus 20 over 5. And we get a nice, what? 3x squared plus 15x plus 4. Is that true for a quotient? Double check my division. Is that right? Did we make a mistake on that one? Oh, what 65 divided by 5 is? It's 13. Good job. Okay. Okay. All right. So GCF 5. We get 5 times 3x squared plus 13x plus your 4. Okay. So you're going to factor again. Factor the quotient. Factor your quotient. That quotient's going to be what recipe? Beef stew or chicken soup? Beef stew. This is the ax squared. Go back. This is your recipe on ax squared plus bx plus c. So you're going to have to go back with that recipe. Now, if you're familiar with trial and error, I'll tell you what this is. 3x and x. I just need factors of 4. I think it's going to be 4 and 1, by the way. These are plus. Double check, see if I'm right. 4 for the last term. My O term is 12x. My I term, x. Oh, it's done. There you go. I factored simply by trial and error. If you guys like, go back and review the recipe. Okay, so this is now factored. We factored this, right, completely. Okay, you okay with this one? All right, let's do 25. Four x cubed plus 21x squared plus your 5x. Okay, what's your greatest common factor here? GCF. It's just x. Good. Let's find the quotient. 4x cubed, 21x squared, 5x, divided by the x. 4x cubed over x, 21x squared over x, 5x over x, don't we get? 4x squared plus 21x plus 5. That's my quotient. Okay, we're going to write this as the greatest common factor times the quotient because we factored out that greatest common factor. Now let's see. Let's see what we do. Factor the what? The quotient. And that quotient is of the form ax squared plus bx plus c. So, okay, we'll do it as trial and error. Some of you guys know this trial and error, some of you guys don't. This is going to be 1 and what? 5, by the way. If you don't know trial and error, that's fine. Use your beef stew recipe, okay? And this is what you end up with when you factor this recipe here. Okay? This is number 25. Anybody have any questions on this one? You sure? That leaves us up to 27. So let's see. 6x to the fourth plus 33 x cubed minus 18 x squared. Okay, what's your greatest common factor? 3 x squared. Good. Let's find the quotient. Remember, greatest common factor first of 6, 33, and 18 is 3. X to the fourth, x cubed, x squared, always x the smallest power. That x is common. It's in every term. So that's why it's 3x squared. And then, if we go back and try to find this quotient, we take the 6x to the fourth plus the 33x cubed minus 18x squared over the GCF of 3x squared, and we get 6x to the fourth over 3x squared. 33x cubed over 3x squared. Minus 18x squared over 3x squared. What do you get? 6x squared plus 11x minus 6. Is that true? Is that what you get when you get this quotient here? What do you guys think? Is that right? 6 over 3 is 2, right? Wait a minute. Ah, it's supposed to be a 2. Thank you. 6 divided by 3 is 2. 33 divided by 3 is 11. 18 over 3 is 6. And then, you get your x squareds canceling, and then you get your power of x here. Look at, subtract your powers. 3 minus 2 is 1, and 4 minus 2 is 2. Okay, here's the quotient. So, all together, let's see what we get. 3x squared times 2x squared plus 11x minus your 6. So remember, you factor this quotient, and you notice that this is of the form ax squared plus bx plus your c. So we're going to have to use that factoring technique, that recipe, beef stew. Is that true? Chicken noodle? Or you could do what? Trial and what? Error. So 2x squared and x, these are the factors. But I have to factor 6 and 3. And let's be careful with the signs here because we got a negative sign there. So factors of 6 and 3 are like 6 and 1 and 2 and 3, right? So I have to find factors such that they add up to 11x when I do FOIL. Anyway, anybody know what that might be? I think it's 6, 1, plus 6 minus 1, because 2x and 6 is 12x. Is that right? Negative 1 and x is negative x. Is that positive 11x? Sure is. Or use the what? Recipe. Moral of the story? We are what? We're done. Factored completely. Okay? That's 27. So 29 Solve x to the fourth. Minus 68x cubed plus 40x squared. What's the greatest common factor? GCF. 12, 68, and 40. Is it 4? Okay. What about for the variables? X to the fourth, x cubed, x squared. X squared. Okay. So let's find the quotient. So I have x to the fourth minus 68x cubed plus 40x squared divided by 4x squared. Okay, let's see what we get. 3, is that 3x squared minus, what's 68 divided by 4? Is that 17? Good job. 40 divided by 4. Well, that's just 10. X squareds cancel, right? Here's my quotient. Okay. Here we go. 4x squared times 3x squared minus 17x plus my 10. Okay. Factor the quotient, and we know we got to use the ax squared plus bx plus c technique. Or you could do this by trial and error, sort of. Find factors of 3x squared, 3x, and x, and factors of 10. There's 2 sets, 5 and 2, 10 and 1, but they have to be such that they add up to the O and I term, the negative 17x. So these terms have to be probably negative, right? The only way you could add terms together and be negative is if, well, one way is if both are negative, but the product's positive, so. Let's see, what are factors of 10? 2 and what? 2 and 5 is 10? So if this is 2 and this is 5, right? Should they, what should the signs be? Negative? See, a negative times a negative is a positive 10. So does this give me the O and I terms? Negative 15x minus 2x. Is that negative 17x? Yep, looks like we're good. So it's up to you. I would say to you, if you invested wisely in your beef stew recipe, then use the beef stew recipe. Okay, just might take you some extra time, but that's okay because you want to get it right anyway. So it's not an issue where you say, well, that'll take me too long. That's okay. That's how you learn this recipe really, really well. Okay, so that's 29. And then you have 31. Let's see, 25x cubed minus my 15x squared minus my 10x. Greatest common factor. What do you guys get? What's the GCF here? 25, 15, and 10. What's the GCF? 5. X cubed, x squared, and x? X. Good. We just need our quotient. 25x cubed minus 15x squared minus 10x. Everything over that 5x. Now let's see what we get. 25x cubed over 5x minus 15x squared over 5x. 10x over 5x. Now let's find the quotient. 5x squared minus 3x minus 2. Is that true? All right. So 5x times 5x squared minus 3x minus 2. Okay? Notice, I'm going to have to factor this quotient, and again, ax squared plus bx plus c. So factor the quotient either by trial and error or by your factoring recipe, by that beef stew. All right, 5x squared, 5x and x. the number 2 is 1 and 2. Is that right? Factors of 2 are 1 and 2 for the last term. So we need these factors. So this is 2 and this is 1. Which one should be positive? Which one should be negative? 1 is negative and 2 is what? Is that true? I think you're right. Negative 5x and a positive 2x, negative 3x. Okay. We are what? Done. That's it. Good. So that's 31. 33. Okay, look at this one. X to the 4th minus that 4x. What's the greatest common factor? Is that what it is? That's x cubed, sorry. What's your greatest common factor of x cubed and 4x? What's the GCF? Is that just x? Okay. And then what's the quotient? X cubed minus 4x over that x. X cubed over x minus 4x over x. What's my quotient? Is that x squared minus 4? Okay, let's put this together. GCF is x squared minus 4 here. And what's this process known as? Factor what? Completely. So I have to factor the quotient. Now, we had the chicken, what do we have? The chicken soup recipe. We had the beef stew recipe. How many terms are here? 2 terms. And do you guys recognize this as a special factoring idea here? Isn't this a squared minus what? B squared? Isn't that the difference of perfect squares? Is that true? So even the difference of perfect square formula comes in here for factor completely. So if you worked on all those problems, x squared minus 4, a squared minus b squared. X squared, what's the base? X. 4, isn't that 2 squared? What's the base? 2. Plus and minus. You had factored this completely. So the point I want to make is that your special factoring formulas do also come into play for your quotient, if that's what you get. And that's what we got here. My quotient was x squared minus 4. So all the things we did with factoring, are going to come back. And, we have to be proficient with factoring. So you factored this completely. Okay. Let's see, number what? Number 35. All right. We have x cubed minus 25x. So, greatest common factor of x cubed and x. Isn't that just x? Okay, quotient. X cubed minus 25x. Everything over x. We get x cubed over x. Well, we can write it over here, I guess. X cubed over x minus 25x over x. And this gives you x squared minus 25. This here is the quotient. Okay, so let's write what we have. We have GCF, quotient. Factor the quotient. Sure enough, difference of perfect what? Squares. So we did our homework. Base for x squared is x. Isn't 25 5 squared? This would be 5 plus and what? Minus. Good. Good. That's 35. Anybody have any questions on 35?
For the ones with perfect squares, you could just put x minus 5 to the second power, right?
No, be careful. Be careful. It's a good question. You see this difference of perfect squares? Your signs must be plus and what? Minus. Don't put the power 2. The question is, can we put this final answer as x times, x plus 5 to the power 2? No, because what does that mean? We got 2 copies of this x plus 5. They're not what? Plus and minus. Oh, they're the same. Okay. Yeah, so the answer is no. Don't use that power 2 for the difference of perfect squares right there. Okay? Okay, that was, let's do number 37. Let's see what 37 is. We get 5x squared minus 5. We need a GCF. What's a GCF? 5 and 5. What is it? 5. X squared and no x. X is not even common. So that means my GCF is simply what? 5. Good. Now, quotient. 5x squared minus 5 over my 5. Let's see what this quotient is. 5x squared over 5 minus 5 over 5. What's that quotient? X squared minus 1. So, 5 times x squared minus 1. Factor the quotient. What's the quotient? Difference of perfect squares. You guys okay with that? Okay. Did the difference of perfect square homework. What's the base for x squared? X. What is 1 squared? Isn't that 1? So what's the base for 1 squared? 1. Always use plus and minus. Plus and minus have to be there, and this is how you write your answer. Okay, this is factoring 5x squared minus 5 completely. Okay, now number 39. Five x cubed minus 25x. What's your greatest common factor? 5 and 25, isn't it 5? X cubed and x. What is that? X. Good. Let's find the quotient. 5x cubed minus 25x over my 5x. This is going to give me my quotient. So, this is 5x cubed over 5x minus 25x over 5x. What's my quotient going to be? 5 goes away. X squared. 25 divided by 5? That's minus 5. Is that true? I think there's a typo here. Here's a typo. Should be 125. Okay? Now, what does that give me? You know what this gives me now? That's x squared minus what? 25. So that number should be a 125. Okay? Now, here we go. 5x for the greatest common factor. X squared minus my 25. And what do you guys notice again? The difference of what? Perfect squares. So, how do we factor this? Don't forget, x plus minus, isn't 25 equal to 5 squared? What's the base? 5. Good. You factored completely. Okay? We got one more to do. One more. 2 more, sorry. X to the 4th minus 49x squared. Greatest common factor. What is that? X squared. Good job. Let's find the quotient. X to the 4th. 49 squared. Divided by x squared. Let's see what we get. X to the 4th over x squared minus 49x squared over x squared. X squared minus 49. Okay. GCF, x squared. Quotient. X squared minus what? 49. Factor the quotient. Difference of perfect what? Squares. X squared. Sorry. See if we can see. Okay. Difference of perfect squares. X and x. Plus and minus. What's 49? Isn't that 7 squared? Base is 7. You factored completely. Now let's do the last problem here. Okay. X to the 4th minus 36x squared. What's your greatest common factor of x to the 4th and x squared? X squared, good. Quotient. X to the 4th minus 36x squared. Everything over x squared. X to the 4th over x squared. 36x squared over x squared. My quotient is x squared minus 36. Good. Here we go. X squared times x squared minus 36. What do? Factor the quotient. What is the quotient? A difference of perfect squares. How do I factor a difference of perfect squares? X plus, x minus. What's 36? 6 and 6. We're factoring, what's the term? Factoring what? Completely. Good job.